And welcome back, and it's the higher plus 5 a day, and we're going with the 28th of January today. So what have we got today? It's a good question. It's a good question because some people might think the way to do this is to divide by 5, which means that x squared is less than 9, take the square root, which means that x is less than 3, and that's my answer. It's not. Got to be very careful. Because it's a squared here, this is actually a quadratic inequality. So I can do the first step. I can divide by 5, which gives me x squared is less than 9. That's fine. Then if I move the 9 to the other side, I have a quadratic. And if I factorise that quadratic, that's x minus 3, x plus 3, difference of two squares, which means I have a quadratic which goes through minus 3 and 3. And I want all values that are less than 0, which means my answer is minus 3 is less than x, which is less than 3. Now, quick check, that is a strict inequality, which means that this needs to be strict as well. Question done. Next question. Okay, the box plot shows information about the masses of apples in a box. Jack picks 3 apples at random, one at a time, replacing each before picking the next. Okay, this is interesting. So this is a probability question. Find the probability that chooses. Now, key to box plots is this here represents 25%, that's 25%, that's 25%, and that's 25%. Everything about box plots is quartiles. So the probability that you choose over 90 is equal to 25 plus 25, which is 50%. And the probability of under 75, because it's from here, is the 20, well, let's write it down. So under 75 is equal to 25%. Now, picks 3 apples, replacing each time. So I want 2 over 90 and 1 under 75. So I could do over, under, over, over, or under, over, which are all going to be the same calculation. So it's going to be 3 lots of 2 overs, which is 50% squared. Let's write 50%. So let's do a half. It's a better number. So a half squared times by a quarter. Right, let's do this carefully. So a half squared is a quarter times another quarter is a 16th. So that is going to give me 3/16. Good question. Nice little combination question. Well set out. Next question. The minimum point of a quadratic graph is in the form of this. Find A and B. Right, 2 ways of doing this. Way 1 is you sort of do a reverse complete the square and then solve for A and B. The much easier way is you know the vertex is minus 2 minus 10, which means the completed square form must be x plus 2 squared minus 10. And if I expand this, that's going to be x squared plus 4x plus 4 minus 10, which is minus 6. And if I write down what I'm starting with x squared plus ax plus b. It means that a must equal 4 and b must equal minus 6. Nowhere near as bad as it looks, is it? But good question. Next question. I think it's going to be Pythagoras then. A, B, C, D, M, N, P are squares proof. Right. Okay. As you may have seen me say in other videos, so I won't write a lot of stuff down because otherwise you'll just see me writing for a while and you won't be able to read it. But I'll talk through what you need to do. Congruent means the same. Now, actually, I haven't taught this for quite a few years, but from the depths of my memory, you either need to show it's an SSS triangle or an ASA triangle, or there's another one, isn't there? Is it SSA or ASA? I can't remember. SAS, isn't it? That's what the other one is. Now, I think I'm going to go with ASA. And my argument is going to be, again, I'll be writing this down properly, but I would argue that it must be the case. And well, actually, first of all, let's note my triangle. So this is triangle 1. And I'm going to do the other triangle in red. So this is triangle 2. I want to show that these triangles are basically the same triangle, just moved around. Now my argument is going to be, first of all, I'm going to do a side. So I'm going to state that OP is equal to PM. And I'll say something like sides of a square are equal because it's a square. So sides of square are equal. Obviously in an exam I'll be writing 4 words out. Then my thinking is going to go, well, my x angle I'm going to do in red, and this here must be 90 minus x because this here is a right angle, as is this over here. And the reason that's important is because the green angle is 90 minus x, and because that's 90, this is 180 minus 90 minus 90 minus x, which is x. obviously I'll be writing that down by saying angles on a straight line equal 180, angles inside a triangle equal 180, etc. But that would be what I'm trying to argue. And that must then mean that this angle up here is going to be 90 minus x, because angles in a triangle total 180, and therefore I have proven, let's be really clear what I've proven. I've proven that this side here and this side here has the same two angles attached to it, so therefore I have proven it by ASA. And again, that is because if I draw a side of the same length and draw the same angle and the same angle, there is only one triangle I can draw, which is this triangle here. So I've proven it to be congruent by ASA. Nice question. I haven't actually taught that in a very long while, so I'm quite glad I managed to remember that. So well done if you got all those. Nice mix of questions today as ever. Please do subscribe. I really want to try and get more people on this channel, and I'll see you for the next one. Thanks all.